Hello, discrete math fans. Let's try this problem. I'll give you a list of numbers, 13, 14, 15, 16, all the way up to 65. And I just ask how many integers are in this list. All right, the easy but incorrect answer is just to say, well, do 65 minus 13, last number minus first number, that gives me 52. Well, this is wrong. How can we see that this is not right? Let's try an easier example. How many numbers are in this list? 4, 5, 6, 7, 8, 9, 10. Well, now we can just count them. There's 7 numbers in that list. So we should be able to see pretty easily, you don't just take the last number and subtract the first number. You'd get 6. That's not right. You got to add 1 to that. Now let's go back to our original problem of counting the numbers in the list 13 up through 65. Well, what do? We just do 65 minus 13, but then we have to add back 1, so we get 53. So this gives us a theorem. The number of elements in a list from m to n, well, you'll get n minus m plus 1 integers. And that's counting the number of numbers between m and n inclusive. Okay, let's try this one. How many 4-digit numbers are divisible by 7? Well, the 4-digit numbers range from 1,000 to 9,999. If we look through the numbers, the first number that's in the list that's divisible by 7 is 1,001, and that's 7 times 143. The last number in the list that's divisible by 7 is 9,996. That's 7 times 1,428. A little wimpy calculator will help you figure this stuff out. All right, so the list that we're actually counting starts at 1001, and then we can go by 7s. 1001, 1008, 1015, and so on. But that's not really all that straightforward to count. I mean, you could do it if you just counted them out, but there's a better way. Let's rewrite this list. So as we saw, the first thing in the list is actually not 1001, but 7 times 143. So we put that in here, 7 times 143, and then the next one, 7 times 144, and so on. And the last thing in the list is 7 times 1,428. Well, now if you think of this as just adding up or counting how many things are in this list from 143 to 1428, we get our answer. And the answer is 1,428 minus 143 plus 1, and we end up with a final result of 1,286. So that's how many 4-digit numbers are divisible by 7. So this is a counting problem. We're counting how many of these things happen. We give a condition that defines a set, and then we count how many things are in that set. And we do so without actually enumerating one by one the things that are in the set. We're trying to do this in a more sophisticated way. Okay, that's all for now.